company's cost to make Q shoes is C equals F of Q dollars. What a weird thing to say. It's abstract. It's an idea. There's some function, F, that when you plug in Q, the number of shoes the company is going to make, it gives you the cost. Does that mean it's got some formula? Possibly. Does it mean it's an accurate formula? Possibly. But we're not worried about an actual formula here. We're worried about the idea. Explain the meaning of the following statements. F of 10 equals 250 and F prime of 10 equals 7. And what is the practical meaning of the derivative F prime of Q in general? You got to think about the variables and their meaning, as well as the fact that a slope is a rate of change to help you do this problem. F of 10 equals 250. Does the 10 represent a value of Q or a value of C? It's Q, because that's what's going into the function. That's the function input, F of Q. So it's implicit here that 10 is a value of Q, the number of shoes made. So you're making 10 shoes. And the 250 then must be the other variable, $250. By the way, when you say C equals F of Q dollars, you mean C is in dollars. C is a cost here. So the letter used is suggested. Q is a quantity of shoes, Q. So F of 10 equaling 250 means it's going to cost you $250 to make 10 shoes. It's not how much you can sell them for. It's how much it's going to cost your company. F of 10 equals 250. That's a Q value. This is a C value. Means it costs $250 to make 10 shoes. That's how you answer number 11, part A. Oh, this is going to be trouble. Number 11, part A, to explain the meaning of that statement. The derivative one's a little harder. F prime of 10 equals 7. F prime of 10 equals 7. The input variable for the derivative is still Q. This is still a number of shoes, a quantity of shoes. But the output for the derivative is not a value of C. It's not a cost. Does anybody want to take a stab at what to call it? Mm-hmm.
Change in the amount of dollars per shoe.
That's close. I'd add an extra word in there. What word should be added into the phrase, the change in the amount of dollars per shoe? Instantaneous. Looking for one word that starts with R. Rate. Rate of change. It's a derivative. Derivatives are rates of change. They are slopes of tangent lines. Slopes are rates of change. They tell you how fast a function is increasing or decreasing. The steepness of the graph reflects how fast the dependent variable changes as the independent variable changes. On Wednesday, we'll make some animations to illustrate that. We've done that before when we talked about physics of going up and down. We talked about the derivative as a rate of change, and when the slope is higher, for example, the balloon is going up faster than when the slope is close to 0. 7 is not a C value. It's a, well, in Leibniz notation, it's a dc dq value. What's dc dq? Just a notation for the derivative. We use, go ahead.
Changing cost over change in quantity.
Yeah, change in cost per change in quantity. DC, DQ. Where do the D's come from? Well, they're kind of similar to the Greek letter delta. In fact, the word delta starts with D. Delta is the Greek version of D. So it's kind of analogous to a change in C divided by a change in Q. It's analogous to a fraction. Hey, a rise over a run, maybe? It is analogous to that. Why do we use D's instead of deltas? Don't want to get into that right now. It's tricky. Okay? For the moment, just say, hey, that's a notation for the derivative. The rate of change of the cost with respect to the quantity sold or quantity made in this case. Its units are going to be dollars per shoe. This says when 10 shoes are made, and when I write that, it's kind of implicit that they're made during a certain amount of time, maybe a day. When your production is 10 shoes, maybe per day, the rate of change of the cost with respect to shoe production is $7 per shoe. And yes, it is an instantaneous rate of change. Instantaneous rate of change. But if you don't put the word rate instantaneous in there, I won't mark it as wrong. But you got to have the words rate of change in there. Of cost with respect to shoe production is $7 per shoe. Meaning each extra shoe you make is going to cost $7 more. Question?
So would that mean for a regular function that f of 11 would be 257?
You're thinking good thoughts there. Yes. It was said that this means when you make 11 shoes, your cost should be 257, 250 plus 7. That is a good idea. That is almost right. But not necessarily exactly right.
If f prime is within your function, then yes.
Yes.
It's good.
Yes. Your answer would be right if the graph of f is a straight line.
Are you gonna make a half shoe?
Theoretically, you could. You could make a half shoe. We are also idealizing what's going on here. Yes, it's most practical to make whole shoes, but in an idealized setting, it's sometimes simpler to think about being able to make half shoes or quarter shoes or even a tenth of a shoe. And theoretically, you could, right? You could put just half of the shoe together or something. Doesn't mean you can sell it, but there will be a cost associated with trying to do that at least. Question?
What's that WRT?
With respect to. Yeah, WRT in this class will always mean with respect to. What does the graph of the cost versus shoe production look like? I don't know. But we could hypothesize a possibility. It should be increasing. You make more shoes, it's going to cost more. So the graph should have a positive slope. And this derivative is positive. Should it have a positive vertical intercept? Probably, because even if you don't make any shoes, you still have costs. Like you have a building and workers to pay. Okay. Now, of course, in every situation, it's different. How big is your building? How many workers do you have? But for a given company with a given building and given workers and given other costs, there would be some cost for producing no shoes. So the vertical intercept should be positive. Will the graph be a straight line? That's certainly a reasonable thing to try. And you'd have to look at your data to see whether a straight line is reasonable. If I were going to guess, though, This is a little dangerous. I guess concave up or concave down. I think you could probably argue it both ways to some degree. You could argue it's concave up, meaning for each extra shoe you make, as you make more and more shoes, the cost goes up more and more, maybe because your factory is getting flowing. Now, 10 shoes is not going to overflow a factory, but imagine millions of shoes. Okay, maybe you need to buy a new factory. Okay, that would be one argument for maybe why the graph is concave up. On the other hand, you could argue the graph's concave down because each extra shoe you make actually doesn't cost that much more because it's just one extra shoe and you didn't have to hire any more workers. It's just one extra shoe after all. So maybe more efficiency. In reality, it probably is a combination. It might be concave down at first, then concave up, something like that. That's probably closer to reality if I had to guess. Anyway, graphically, we can interpret the information we have as saying that when Q is 10, C is 250, and the slope of the tangent line at that point is 7. I draw the tangent line, the slope is 7. And yes, that would mean that f of 11 should be approximately f of 10 plus f prime of 10 times 1. $250 to make 10 shoes plus $7 per extra shoe times 1 extra shoe. This is in dollars. This 7 is in dollars per shoe. And this 1 is in shoes to give you $257 as your estimate for the cost of making 11 shoes. If the graph truly is concave down there, though, your actual cost is going to be slightly less than 257 because the concave down nature of this graph means the tangent line is above the graph. So it overestimates the function output. It's all hypothetical here, right? I don't know for sure for a given company what this graph looks like. I'm just thinking about possibilities. That is a prerequisite for applying calculus, by the way. You can't really apply calculus in significant ways in real life unless you think about these hypotheticals. These models. Do people actually do this kind of thing? Well, economists certainly do. Business people, maybe not so much, unless they really like calculus. But economists certainly think about this kind of stuff. And they're thinking about the economy and efficiency and so forth. What is the practical meaning of f prime of q? It's telling you how fast the cost changes as the quantity made changes. That's got a special name in economics. It's called marginal cost. What's the cost of making the next shoe? What's the extra cost, I should say? Let's do another example, and then it'll be time to go today. Oh, this one's a little more, another cost example, a little tricky. By the way, I will put up some problem-solving videos again, as usual, and they do include more examples like this, if you want more examples. Suppose C of R is the total cost of paying off a car loan borrowed at an annual interest rate of R%. What are the units of C prime of R? What's its practical meaning? What's its sign? Again, it's a challenge to understand what in the world this is talking about. And in fact, it's good to have some real life experience in this example to understand what it's talking about. To know that the higher the interest rate, the more it's going to cost. When you borrow money to pay for a car or later in life for a home, getting a home mortgage, the interest rate you're charged is very important. It affects your total cost. It affects how much interest you pay. Higher interest rate means higher cost. So certainly this should be an increasing function. So certainly that means, well, its graph is going up. And that means the derivative is positive. Because the graph is going up, the slope of the tangent line is positive. Is the graph a straight line? Concave up, concave down? I know from experience that the graph's going to be concave up. By the way, here, C of R is function notation, and there's no dependent variable that's named. C is the function name here instead of a variable, isn't it? However, that doesn't stop many scientists from writing something like this. C equals C of R. You will see this all the time in your science and engineering classes, maybe even business or in economics classes. They will use the same letter for the dependent variable as the function name. Why? Just because it's sloppy, but just it makes sense. Why bother with a function name F? This is kind of the idea. It's not precise. It's got an official name for it. It's called abuse of notation. I did not say abusive notation. I said abuse of notation. We are abusing notation here. We're using the same letter to represent two different ideas. A variable, C, which is a number, and a function name, C. It would be better to call this F or G or whatever. Some letter other than C or R. But you will see this all the time in science, engineering, business, economics, psychology classes. People will abuse notation. The main thing is just don't let it bother you. Realize it's not super precise math. It's a little confusing. You just say, okay, I don't have to worry about it. It's okay. The graph is going to be concave up. As the interest rate goes up, your total cost, yes, it goes up. But not only does it go up, it goes up at a faster and faster rate. The graph is concave up. So not only is the derivative positive, but the second derivative is positive. That has significant implications. It's telling you at a higher interest rate to begin with, each extra interest rate increase is going to result in a higher increase in your cost. That's bad for taking out a loan, but it's good if you're the banker raking in the cash. Actually, if you flip it around and think of you as the investor, investing in stocks or bonds, well, stocks can go up or down. Bonds are a little bit more stable. The higher the interest rate, the more interest you get. And not only more interest, but you get more interest upon interest you've already earned. It's a concave up graph for you as well, and that's good for you. It's kind of a vague question here. There are no numbers. I've said C prime of R is positive and also increasing, so C double prime would also be positive. What are its units? Think about Leibniz notation. You could write dc dr for the derivative. Again, this is called Leibniz notation. Leibniz notation. Leibniz is a co-inventor of calculus along with Newton. They both lived about 350 years ago. That's when they were in their prime, pun intended. It looks like a ratio. Leibniz actually thought of it as a ratio, and many scientists and engineers think of it as a ratio. Technically, it's not. Technically, if you want to be precise about it, derivatives are not fractions, they are limits of fractions, right? Limits. But it often doesn't hurt to pretend it's a fraction. I'm not going to give this a more precise meaning than that, other than that right now. just think of it as an alternative notation for the derivative in addition to the prime notation. Actually, so Leibniz came up with this notation. This prime notation, Newton did not come up with either one of these. The prime notation, I think, came from somebody named Euler. Euler's name is written Euler. Euler. What are its units? It's a rate of change of cost with respect to interest rate. Change in money over change in interest rate. And then if money's in dollars, this would be dollars per, what should I write? Change in interest rate? Well, probably the best thing to write is percentage point. Percentage. I'm spelling it wrong. Sorry. Dollars per percentage point. Hang on, it's about out of time, but I got one more thing to say here. What is a percentage point? It reflects an increase in a percent. If one loan has an interest rate of 4%, and say that same loan a month later, the interest rate has gone up to 5%, you say it's increased by 1 percentage point, from 4% to 5%. Why do we say percentage point? Because going from 4 to 5 is actually a 25% increase in the percent. But you say it's increased by 1 percentage point. Because 5 minus 4 is 1. A little confusing. We'll talk about it more on Wednesday. Okay, again, you'll want to watch the extra videos related to more problem solving like this to get more examples.